Okay, so what I set up on Mathematica, use the orange marker to point here. So I took our equation, x cubed minus 7x, x cubed minus 7x squared plus 7x minus 1 equals 0. I solve that for x, and it tells me we get x equals 1, 3 minus 2 root 2, and 3 plus 2 root 2.
Yeah, that's what we found.
So to simplify, I'm just calling a equal 1, b equal 3 minus 2 square root of 2, and c equal 3 plus. And then, well, I guess I use g, h, and j rather than x, y, and z, but you get the point. I'm going to solve g plus h plus g, j equals 1. G times 1 to the first power. And so the g code is always times 1. H times b to the first power plus j times c to the first power is 3. That was our second number.
First term.
And now the squareds equal 15, and I solved those for g, h, and j. So g was a half, so the 1 coefficient is a half. The h coefficient, which is times the 3 minus 2 root 2's, is 1/8 2 minus 2 minus root 2. And j was 1/8 2 plus root 2. So they were conjugates, just like you sort of thought they would be. So now I define those numbers as well. And now I just make a function. The function of n is g times 1 to the n plus h times, this was the 3 minus 2 root 2 to the n, plus j times 3 plus 2 root 2 to the n. And it tells me this was f of 0. If I put in f of 1, I get 3. If I put in f of 2, I get 15. So I got 1, 3, 15 to start. So we're hoping that f of 3 was, what was our next number?
85.
85. F of 4?
493.
493.
And 2,871.
2,871. But now here's the amazing thing. I can just find like the 10th number in the list without any problem. Do you remember when we wrote the computer program and it was just searching and searching and searching? Now we can find the 10th number, which if we were searching for that would have taken, well, especially with the way we were doing it, would have been taken forever.
Yeah.
But I can find the 20th number.
We would have never been able to find that.
Yeah, we wouldn't have been able to find that with a computer search. I'll be interested if I can do the 100th number. Does it know? At some point these calculations get hard, but yeah, so it doesn't simplify it. But it turns out this is going to be an integer. And we could simplify it if we felt like it. It would take a long time. It'd be interesting to know where the largest number, where it stops deciding to simplify is. Oh, there's the 50th number. Crazy, huh?
Yeah.
So that's pretty cool. So the linear algebra techniques that you're learning now will tell you, this is one interesting application. It tells you how to, for these recurrence relations, immediately solve them. And now you could use the same technique here to write down, say, the 100th Fibonacci number. And
Probably a bit easier.
What would you have to do to write down the 100th Fibonacci number normally?
You'd have to find all the ones previously and just go start at 1 and just go up one at a time.
Right, you'd have to find all 100. But with these techniques, if I ask you what the 100th Fibonacci number is, you just write it down as soon as you solve the equations. All right?
All right.
All right, good job, man.